300 tons of TNT exploded over Massachusetts on Saturday afternoon. Millions heard it across 3 states. Not one person on the ground saw it. NASA's classification arrived yesterday, a meteor. But the agency skipped the part of the case that the satellite imagery actually shows. There was a storm above Cape Cod at the exact moment the bolide fragmented. That storm should not have existed on the calendar it appeared on, was moving in a direction nor'easters do not move, and is sitting directly between the fireball and every camera in 3 states. Stay with us. This is the part the headlines missed. Yesterday, NASA released its public attribution for the atmospheric event that shook eastern Massachusetts on Saturday afternoon. The agency classified it as a meteor, a roughly 3-foot stony body traveling at approximately 75,000 miles per hour, entered Earth's atmosphere over the United States Northeast at 6 minutes past 2 in the afternoon, Eastern Daylight Time on May 30th. It fragmented at an altitude of approximately 40 miles above ground level. The energy released during the breakup is estimated at approximately 300 tons of TNT equivalent, comparable to a small tactical military weapon released in a single second over one of the most densely populated coastlines in the country. The acoustic shockwave produced by the fragmentation was heard across portions of Massachusetts, Rhode Island, and Connecticut. The felt area spans roughly 12,000 square miles. Thousands of residents logged felt reports with federal databases under the initial assumption that the region had experienced a small earthquake. No seismic source was confirmed. The boom rattled dishes, shook houses, and triggered calls to local emergency services across the affected region. Within minutes, the question across eastern Massachusetts was whether something had exploded, and if so, what? NASA's classification settles the cause. The Massachusetts event was a meteor. The agency's attribution is grounded in satellite data captured by NOAA's GOES-19 geostationary weather satellite and corroborated by eyewitness reports aggregated through the American Meteor Society. The physical parameters are internally consistent. The energy estimate aligns with the diameter and velocity. The fragmentation altitude is consistent with the entry geometry. The classification is correct. What the classification does not address, and what we need to address in this video, is everything surrounding the case that makes it interesting beyond the federal headline. The cloud cover that obscured the bolide from millions of potential ground witnesses. The single satellite instrument that resolved the case. The second cataloged sonic boom event from earlier in the week that remains in the federal record without a source attached. The atmospheric configuration that produced the conditions in the first place. NASA's job was to attribute what hit the atmosphere. The agency has done that job. The structural questions about how the case became attributable and why a comparable case from 2 days earlier did not are still open. The instrument that resolved the Massachusetts case is the Geostationary Lightning Mapper, designated GLM, the lightning detection sensor flown on NOAA's GOES-19 weather satellite in geostationary orbit. The instrument's primary mission is to detect total lightning across the Western Hemisphere in support of severe weather forecasting. It continuously surveys the visible Earth disk for brief flashes of optical light in a narrow band centered at 777.4 nanometers, which corresponds to the spectral line of atomic oxygen. The instrument was not designed to detect meteors. The fact that it can detect them is a fortunate byproduct of its optical sensitivity. On Saturday afternoon, at approximately 10 minutes past 2 Eastern Daylight Time, GLM data showed a sequence of flash detections arranged in a tight linear pattern north of Cape Cod. The detections were inconsistent with conventional lightning. They did not cluster around any active thunderstorm. They aligned in a narrow linear sequence, consistent with a single moving optical source. Exactly what the trajectory of a fragmenting bolide produces when seen from above the atmosphere. Operational meteorologist Mark Margavage, publishing under the handle Meteomark, plotted the detections over the regional satellite imagery and identified the trace as the probable path of a meteor. WBZ chief meteorologist Eric Fisher independently corroborated the interpretation. Other operational meteorologists working in real time converged on the bolide attribution within approximately 90 minutes of the event. NASA's Marshall Space Flight Center then converted the available evidence, the GLM signature, the American Meteor Society's eyewitness aggregation, the energy parameters, into the public attribution that arrived yesterday. The operational precedent for this kind of attribution was established in March of this year, when the GLM on a previous GOES East satellite captured a comparable signature for a bolide entering the atmosphere over Lake Erie in northern Ohio. That case was documented by the Cooperative Institute for Meteorological Satellite Studies at the University of Wisconsin-Madison and is now the standard reference for GLM-based bolide attribution as a federal process. The May 30th Massachusetts case fits the same pattern. Here's the part of the case the standard reporting has skipped. A bolide of the May 30th energy class entering the atmosphere over a populated coastline on a Saturday afternoon should produce visible evidence. Under clear sky conditions, an event of this magnitude generates eyewitness reports of a bright streak, fragmentation flashes, and a slowly fading luminous trail. People outside would see it. Dash cams would catch it, doorbell cameras would catch it, security cameras at gas stations and parking lots would catch it. The visual evidentiary record from a clear sky event of this size over the United States Northeast on a Saturday afternoon would typically run to hundreds of independent video recordings within 24 hours. The visual evidentiary record from the Massachusetts event is essentially empty. There are no widely circulated dashcam videos. There are no doorbell camera captures. There are no convenience store security clips. The American Meteor Society's pending Fireball Reports queue received submissions, but the submissions came in through acoustic channels rather than visual ones. People reported hearing the boom. They reported feeling the shaking. They did not report seeing the fireball because the fireball was hidden from the ground by dense cloud cover. This is the structural reality of the case. The visual confirmation chain that should have produced the bulk of the evidentiary record was eliminated by the cloud deck of an unusual coastal cyclone that was sitting directly above the entry trajectory at the moment of fragmentation. The bolide was on one side of the clouds. The witnesses were on the other. The optical signature of the fragmentation event was visible to a satellite looking down from geostationary orbit, but not to the millions of people on the ground who heard the boom. Acoustic shockwaves propagate through the lower atmosphere, regardless of cloud cover. The sound reached the ground. The visible light did not. The result is one of the more unusual evidentiary cases the federal attribution apparatus has handled recently. An event with substantial acoustic eyewitness coverage and effectively no visual eyewitness coverage, attributed entirely through a single satellite instrument that was looking down from above the cloud layer. The cloud cover that obscured the Massachusetts bolide was not arbitrary weather that happened to be in the area. It was the cloud deck of a coastal cyclone that was, by climatological standards, anomalous in two distinct ways. The first anomaly is the calendar position. Nor'easters are predominantly a winter and early spring phenomenon. Their climatological season runs from November through April. The May 30th event sits roughly 2 to 3 weeks past the end of that window. A late May nor'easter is uncommon. Not unprecedented, but uncommon enough to draw immediate commentary from operational meteorologists tracking East Coast weather. The second anomaly is the direction of motion, and this is the part that makes the storm genuinely diagnostic of the broader atmospheric configuration. Nor'easters in the United States climatology track from south to north. The name comes from the northeasterly winds along the storm's northern and western flanks. The polar front jet stream over North America keeps these systems moving northward along the coastline as a default behavior. The May 30th system tracked from north to south. It drifted from offshore New England toward the mid-Atlantic in a retrograde regime. The Boston Box Forecast Office described the broader configuration as, in the office's exact wording, highly amplified. The Washington, D.C. LWX office described the storm's motion as, again quoting directly, slightly cut off as well as its slightly unusual retrograding track. The use of the word retrograding in an official National Weather Service forecast discussion is the kind of language meteorologists use when a system is behaving outside the climatological envelope. It is not the kind of language used for ordinary weather. The southward motion required an upper-level atmospheric configuration in which the polar jet had been displaced south of its mean position, and a closed upper-level low had detached from the main flow into a quasi-stationary or retrograde regime. The system that produced the May 30th cloud cover was therefore not an ordinary coastal storm. It was a structural anomaly produced by a broader atmospheric configuration that has been the dominant feature of United States weather for the past 3 weeks. At 6 minutes past 2 in the afternoon on Saturday, the airspace above eastern Massachusetts and the immediately offshore waters was occupied by the densest extent of the nor'easter's cloud deck. The system's center was offshore. The cloud structure wrapped around the low-pressure center in a comma-shaped pattern, with the densest mid-level overcast positioned directly over Cape Cod and the Gulf of Maine. This is the cloud deck that was sitting between the bolide and the ground at the moment of fragmentation. The two events were independent in cause. The bolide's trajectory was determined by orbital mechanics, the gravitational interactions of small bodies in the inner solar system, measured in tens of millions of kilometers and years. The cloud deck's position was determined by atmospheric dynamics, the motion of a closed upper-level low across the western Atlantic, measured in hundreds of kilometers and hours. There is no causal connection between the two systems. They both happened in the same place, at the same moment, for entirely different reasons. But the spatial coincidence had a structural consequence. The cloud deck eliminated the visual confirmation chain. The federal attribution chain had to compensate by leaning entirely on the satellite layer. The satellite layer worked. The case resolved. But the resolution depended on a single sensor catching a signature through a needle's eye gap in the sky. And the gap existed only because the cloud deck happened to be where it was. None of this was inevitable. The case resolving cleanly was a fortunate outcome of conditions that could easily have aligned differently. The cloud deck was an active participant in how the case became attributable, not background weather coincident with the meteor event. 4 days ago, on May 28th, the United States Geological Survey added an entry to its earthquake catalog with an event-type designation the agency rarely uses: sonic boom, magnitude 0.0, depth 0 kilometers. Source coordinates 6 kilometers north, northeast of St. Andrews, South Carolina. The event was felt across a radius greater than 100 miles. The USGS, did you feel it? System received more than 1,454 reports from members of the public describing the shaking. Maximum reported modified Mercalli intensity reached level 6, the level at which most people feel the shaking, and dishes break. NASA stated on the record that no fireball had been detected for the South Carolina event. Shaw Air Force Base, home to the 20th Fighter Wing operating F-16s approximately 40 kilometers from the source point, stated publicly that no Shaw supersonic activity had been conducted. McEntire Joint National Guard Base, home to the 169th Fighter Wing operating F-16 Block 52 aircraft approximately 30 kilometers from the source point, did not make a public statement. The South Carolina case has been sitting in the federal record for 4 days now with no attributed source. Unlike the Massachusetts case, there was no satellite signature. There was no GLM flash detection sequence north of any point on the coast. The available federal sensor data was not sufficient to produce a public attribution. the case remains open. The asymmetry between the two cases is not evidence of selective federal disclosure. It is evidence of the structural reality of the federal bolide attribution chain. When the satellite layer catches the signature, the case resolves within hours. When the satellite layer does not catch the signature, the case stays open, sometimes indefinitely. The federal record contains both attributed and unattributed cases of this kind. The South Carolina event is one example of a case where the chain did not reach a resolution. The Massachusetts event is one example of a case where it did. Both events were real. Both produced substantial acoustic reports across populated areas. The difference between them is what the federal sensor network happened to register and what it did not. The federal apparatus for attributing atmospheric bolide events over the continental United States depends, in operational terms, on one instrument: the geostationary lightning mapper. That instrument was built to detect lightning. Its bolide detection capability is a secondary affordance of its optical sensitivity, not a deliberately engineered design feature. There is no second operational sensor system whose primary mission is the real-time public attribution of meteor entries over United States territory. There are research programs that catalog the population of near-Earth objects in space. There are partnerships with the Comprehensive Nuclear Test Ban Treaty Organization that catch some atmospheric events through global infrasound monitoring. There are military sensor systems that detect bright atmospheric events as part of missile warning operations. But that data is generally not released to the public on the timescales needed for a public attribution within 48 hours. There are radar networks that catch some events under specific conditions. None of these provide what the GLM provides when it catches a signature: a fast, public-facing, federally sourced attribution that the news cycle can report. The detection threshold for the GLM at the May 30th energy class, roughly 300 tons of TNT equivalent, is in the range where some events register and others do not. The detection probability depends on the optical brilliance of the fragmentation, which depends on the body's composition, its entry angle, the fragmentation altitude, and the geometry of how the flash propagates through the upper atmosphere relative to the satellite's line of sight. Estimates from researchers who study the population of bolide events put the GLM catch rate at this energy class somewhere around 50 to 70% under reasonable conditions, with substantial uncertainty depending on the specific event. What that means in practice is that the GLM catches most bolides of this size that occur in its coverage footprint, but not all of them. The ones it doesn't catch don't disappear. They produce the same boom, the same shaking, the same public reports. They go into the federal record as unattributed acoustic events. They sit there. Most of them never generate news coverage because there is nothing to report beyond loud noise heard. Source unknown. The South Carolina case is one example of a case in this category. There are others in the catalog. The implication is that the actual rate of bolide events over the United States is higher than the rate the public hears about, and the difference is in the unattributed entries that don't generate coverage. The cloud cover that obscured the Massachusetts bolide is a product of the broader atmospheric configuration that has dominated United States weather for the past 3 weeks. Meteorologists call it an omega block, named after the Greek letter whose shape the configuration traces on an upper-level weather chart. A ridge of high pressure sits over the central United States. Troughs of low pressure flank it on either side. The ridge and the troughs together form a quasi-stationary wave that anchors weather systems in place for unusually long periods. Storm systems get stuck. Heat waves persist. Cold air outbreaks persist. The atmosphere stops moving the way it normally does. The current omega block is not breaking down on the timeline a climatological mean would predict. The Climate Prediction Center's day 8 to 14 hazards outlook has the block holding through the first week of June. The Weather Prediction Center's medium range discussion describes the broader pattern as transitioning more zonal mid to late next week, with downstream ridging spreading above normal temperatures from the central United States into the east by the weekend. The pattern is evolving, but it is not yet releasing. The conditions that produced the May 30th cloud cover are still in place. The Storm Prediction Center's day. Two convective outlook for Monday, June 1st, today, places a slight risk of severe thunderstorms across parts of the Central Plains. Large hail and severe wind gusts are expected as the same configuration produces its next round of surface weather. The severe weather setup in the plains today is a product of the same atmospheric architecture that produced the cloud cover over New England on Saturday. One configuration is producing multiple kinds of surface weather simultaneously across different parts of the country. The cloud cover anomaly and the severe weather setup are not independent phenomena. They are two expressions of the same parent pattern. There is one more feature of the Massachusetts case that the broader meteorological configuration may help explain. The geographic distribution of the acoustic reports, 12,000 square miles across 3 states, is unusually wide for a fragmentation event of this energy class at this altitude. Under standard atmospheric conditions, a 300-ton TNT equivalent event at 40-mile altitude would produce audible reports over a roughly 50 to 100-mile radius from the ground projection of the fragmentation point. The May 30th reports extend well beyond that range, particularly toward the southwest into Rhode Island and Connecticut. The Boston Box Forecast Office documented atmospheric conditions on Saturday afternoon that may help explain the wider acoustic footprint. The lower atmosphere was characterized by lapse rates of 8 to 10 degrees Celsius per kilometer in the 1,000 to 950 millibar layer. That is a steep lapse rate. It indicates active vertical mixing under the cyclone overhead and a strong temperature contrast in the lowest kilometer of the atmosphere. The office also noted an anomalously low altitude for the 925 to 850 millibar low-level jet. A narrow band of strong horizontal wind that typically sits a couple of kilometers above the surface, but was unusually low on Saturday. These conditions are favorable to a phenomenon meteorologists call acoustic ducting. Sound waves travel faster through warm air than through cold air. When a shockwave from a high-altitude fragmentation event propagates downward into a region of strong vertical temperature contrast, the acoustic rays bend in response to the changing speed of sound across the gradient. Under a steep low-level lapse rate combined with a low-altitude jet, the rays can be deflected back toward the surface rather than dispersed upward. The shockwave energy gets trapped in a propagation channel that allows it to travel substantially farther horizontally than it would under a typical atmospheric profile. This is a speculative mechanism. The science of acoustic propagation under amplified pattern conditions is not as well developed as other branches of operational meteorology, but the mechanism is consistent with the conditions that were documented over New England on Saturday afternoon, and consistent with the unusually wide felt area reported by the public. The same atmospheric configuration that hid the fireball from millions of ground observers may also have made the boom audible across 3 states rather than just one. Here is where the case leaves us. NASA's classification of the Massachusetts event as a meteor is correct. The bolide was real. The energy estimate is consistent with the physical parameters. The federal record now contains a settled cause for the May 30th event. The case is closed in the strict procedural sense. But the case is best read not as proof that the federal attribution system always works. It is best read as proof that the system worked on May 30th, in this specific instance, under conditions that happened to be favorable. The cloud cover that eliminated the visual confirmation chain was a meteorological anomaly produced by an atmospheric configuration that is itself anomalous. The satellite that caught the signature is the only operational federal sensor whose secondary capabilities cover this kind of event in real time. The catch was contingent on the bolide's optical brilliance happening to exceed the instrument's detection threshold. None of these conditions were guaranteed. The South Carolina case from 4 days ago is a federal record entry where conditions did not align, and that case is sitting in the catalog without a source and may never get one. The Omega Block configuration that produced the May 30th cloud cover is forecast to persist through the first week of June. The Weather Prediction Center's medium range guidance describes the pattern as transitioning more zonal mid to late next week, but not before producing several more days of the kind of stationary weather that has dominated the country. Severe weather is forecast for the Central Plains today as the same parent pattern produces its next round of surface impacts. The conditions that hid the bolide on Saturday, the dense overcast, the amplified atmospheric stratification, the closed upper level low parked over the western Atlantic, are not finished. What to watch for over the coming days. Whether any additional cataloged acoustic events emerge in the federal record over the next week, as the pattern continues to produce conditions similar to Saturday's. Whether the South Carolina case from 4 days ago gets any additional sensor data attached to it as the broader incident response continues. Whether the Omega Block's transition to a more zonal flow proceeds on the timeline the Weather Prediction Center has forecast. And whether the public hears about any additional cases that resolve through the satellite layer, or whether the federal record simply accumulates more entries on the unattributed side without generating news coverage. The Watchroom will be tracking this as it develops,